So we're back now with chapter 1. This is going to be a lot easier for many of you in the beginning, but remember we're at the trig level now, trig and analysis level, so the rigor is going to be up there, but most of this content you've seen before. So we'll start with this quick warm-up. Example 1, graph this line, right? So most of you know how to graph a line accurately at this point. So what I'm going to do, and when you graph it, you're going to graph it most likely using the slope-intercept form method, and that's perfectly fine. What I'm going to do is I'm going to show you a method you probably haven't used in a while, which is graphing via the x and y intercepts. So if you remember, when you're looking at the x-intercept, that's the x-axis here. The y-coordinate is always 0. So what we'll do is we'll plug 0 into the y variable here and solve for x. And for the y-intercept here, the x-coordinate is always 0, so we'll do the same thing. We'll plug 0 into x and solve for y. No need to use this method unless it specifically says graph using the intercepts, but here what we're going to do is we're going to find the x-intercept first, so we're going to plug 0 into y in the equation here. And we end up with x equals 6, giving us an x-intercept, which must be written as a coordinate point, 6, 0. And then we're going to repeat this process for the y-intercept now, where we're going to plug 0 into the x variable and solve for y, giving us y equals -4, y-intercept here at 0, -4. Again, if you're identifying intercepts, identify them as coordinate points, not just the value where the line crosses the x or y axis there. So it's going to hit x-axis at 6 and the y-axis at -4. So I'm going to plot my 2 points and then draw a line with a straight edge. Make sure you have arrows on both ends of your line. Make sure your line is straight. And this is our graph. Again, alternatively, you can do this with the slope-intercept form method, or you could even make a table, but you want to look at what's the most efficient method for you. Next example here, right? So we have a linear equation, right? So we have 2 forms mainly that we're working with. We'll introduce a third form later, but we have the slope-intercept form, y equals mx plus b, and standard form, ax plus by equals c. One thing about standard form, just to note, is that standard form contains no fractions in the equation, and the leading coefficient of the x variable must always be positive, right? And it must be written in this order, ax plus by equals c. So we're going to graph 3x plus 2y equals 18, find the intercepts. So we're going to do this using the x and y intercepts, same method. So we're going to repeat that process. Again, alternatively, you can do this any way you really like, but unless it says use the intercepts here. So I'll hop to this screen here. I'm finding the x-intercept the same way I found it in the warm-up, end up with x equals 6. So I have an x-intercept here at 6, 0, which I plotted right here in blue. Y-intercept is, so I'm going to plug 0 into x, solve for y, get y equals 9. Y-intercept is the coordinate point 0, 9 right here in green. Plot the 2 points, draw my line, make sure you have arrows, make sure your line is created with a straight edge, and we're done with this example here.